Alright, so in this video I want to talk a little bit about comparing two things that you've seen in this chapter already, the reaction quotient, or Q, and the equilibrium constant, K. Because we're going to be doing a couple of questions where, based on some information that you're given, you're going to predict which way the reaction's going to shift or is currently working. And in order to do that, you have to understand what the difference is between Q and K and how they're related in terms of equilibrium. So if we just do a particular example here, alright, we've got N2O4 gas, which is in equilibrium with 2 molecules of NO2 gas. Alright. Now everybody knows that you can write out the reaction quotient or the equilibrium expression for this, and it's exactly the same in each case. It's the concentration of NO2 squared over the concentration of N2O4. Okay. But let's talk about comparing these two. Alright. Because we can have three possible scenarios in terms of our Q and our K. Alright. The first scenario, and the one that's least likely to see, but we should cover it anyway, is where Q is exactly the same as K. Now, it's important to understand what that actually means. If Q and K are exactly the same thing, then that must mean K has been reached, therefore the equilibrium has been reached. And that's exactly what is the case. When Q equals K, your system is already at equilibrium. Okay? But like I said, that's a rather unlikely case that you're going to see. So let's look at the other two possibilities. You have the situation where your Q is going to be bigger than K, or the case where Q is going to be smaller than K. And let's deal with each one separately. Alright? Hi Emma. Sorry, I have my cat here and she is getting all over the place. Go on. Go on, piss off. Thank you. So, what this means is that Q is bigger than K. Hello again. Okay. Q is bigger than K. Alright? And if I just write out, Emma, piss off. Little shit. Okay, sorry about that. When I write out my expression for Q, from what we said before, it looks like this. Okay. Looks like so. And if I have my equilibrium concentration, that's equal to K as well. But when my Q is bigger than my K, that means this top number must be too high. Therefore, my concentration of products must be too high as well, which means I have to find a way to decrease that concentration. And that means shifting away from the products towards the reactants, thereby increasing this N2O4. Okay? So what that means is Q needs to decrease to equal K. So it has to become less to be equal to K. Once it equals K, then it's at equilibrium. So the only way for Q to decrease is if you increase the reactants and decrease the products. And so the only way that's going to happen is if the equilibrium shifts to the left or towards the reactants. Okay? And it's absolutely the opposite for when Q is less than K, because in this case it means Q needs to increase to be equal to K. Okay, so Q needs to get bigger, so this value needs to increase, so therefore there need to be more products. And so in this case, the equilibrium shifts to the right, or towards the products. Okay, and those are the three possibilities of predicting Q versus K. Alright, let's just do one example. Let's actually use the the equilibrium that I just had on the previous slide. So we'll say that this is true. What I'm going to do is to give you the value of Kc for that equilibrium that's already been experimentally determined. Is 0.21 at 100 degrees C. Remember, the values of Q and K are unitless because they're just ratios of concentrations. So then we have the rest of the question. It says at one point during the reaction, the concentration of N2O4 is 0.12 molar. Okay, and at that same time, the concentration of NO2 is 0.55 molar. So the first question is the reaction at equilibrium? Okay. So the answer to that is going to be either yes or no. And if the answer is no, which way is the equilibrium shifting if the answer to the above question is no? So let's handle the first question. Is the reaction at equilibrium? All right. How would we figure that out? We have our equilibrium constant, but we don't really have anything else. We have these concentrations, but what do you think we can do with them? Well, what we can say is, the question says these concentrations are at some point in the reaction, so I can write out my expression for my reaction quotient. I know that that is exactly what I said it was before, NO2 squared over N2O4. So when I square my concentration of NO2, that becomes 0.55 squared, and that's all divided by 0.12. Now, when I multiply and divide all that out, I get a value of Q of 2.5. So the first thing you can very easily tell, because Q is not the same as K, that the reaction is definitely not at equilibrium. But we can also tell which way the equilibrium is shifting. Okay? Because we can see that Q is bigger than K. And when we go back to here, we said Q is bigger than K, so Q needs to decrease, so the reactant's concentration has to increase. Okay, so the equilibrium's got to shift to the left. Equilibrium is shifting to the left. And that is exactly how you work out reactions or questions like that. Okay? All right, thank you.